Okay, continuing our discussion of iterations implemented using the while loop. We're going to go over some examples. I'm going to use the same examples that I used when I introduced the for loop. So let's get started. And I'm going to illustrate the use of the for loop and the while loop side by side. Now, something interesting to note with the for loop, if you recall, we had two styles. We had the direct access as well as the indexing. Well, the way the while loop works, the for loop allows you direct access, which is an interesting feature of the for loop. The while loop does not. So with the while loop, what we're going to be using specifically is the indexing method. So we'll be using the indexing method, the same principles behind the indexing method that we use with the for loop with the while loop. So let's look at a couple of examples. The first example, if you recall, was just to display the items in a vector. And so on the for loop side, if you recall, if we had some vector A and it equaled just a set of numbers 23, 42, 16, 8, and 12. And we would do 4 x equals 1 colon length of A. This is the indexing method once again. And simply we would display A indexed at x. Okay? And then we would end that. So this is a script to show how we do in the with the for loop. Now, contrastingly, we're going to do it over here with the while loop, and I'm going to point out the changes. I'm going to point out the changes over here. So we do the A equals 23, 42, 16, 8, and 12. Just for correctness, I'll put the semicolons there. It doesn't matter here. X equals, now this is where it changes. I'm going to identify my X. Remember our three things. We have to initialize, we have to inspect, and we have to increment. Okay, initialize, inspect, and increment. And that's what we have to do over here on the while loop side. This is the while loop side. Okay, so this this represents the initialization. So this is the initializing of the loop variable x. So our loop variable is x here. Sort of like x over here. So we're going to use this x in the while just like we use this x in the for. It's just the for loop does the initializing, the inspecting, and the incrementing for us. Over here we have to do it ourselves. So x equals 1, that's the initializing stage. Next up we're going to start the while loop, while, and then this part of the while loop is actually the inspection. While x is less than or equal to the length of A. So this is, we're inspecting our loop variable x to make sure if it has reached our terminating condition yet, and telling us when to stop. So that's the inspection phase. And then we're going to do some code block here. But the key is that within the code block that we do inside the while loop, we have to increment. We have to do our incrementing part. And so the incrementing here is x equals x plus 1, which adds 1 to the value of x each time we go through the loop. Then we end the loop. So this is the incrementing part. Okay? So we initialize x equal to 1. We inspect x at the top of our while loop here. We expect x to see if it has reached our terminating condition. See if we should continue with the loop or not. And then we increment x every time, so we're getting closer to our terminating condition. Because if we don't get closer to our terminating condition, this loop will never stop. Again, we increment x here to 1. We test x here to see if this logical statement is true or false. This is a logical statement just like the ones we used in the if statement. So we check this logical statement. If this logical statement is true, then we execute this code block. When this logical statement becomes false, when it becomes false, we no longer execute the while loop. Okay, so there's a lot going on here, and there's a lot at play here. Once again, let me go ahead and do sort of a diagram, sort of bring this one home. So if I did this in a diagram, if I have enough space here, this is our defining A. 23, 42, 16, 8, and 12. The next block, if you recall what I did before, is the initializing block, which is x equals 1. Right? So that initializes our loop variable. Then you get down here into the actual while loop conditionals. So this is while, and then we have our logical expression that we're going to evaluate every time through the while loop, and this is our logical expression here is x is less than or equal to the length of a, which is going to be a common form that we use. If that is true, while x is still less than or equal to the length of a, then we execute our code block here, which in this case is just the display of a sub x. And you also have to make sure, it's almost like this code block has a necessary part, which is the actual incrementing of the loop variable, so that we can get closer and closer and eventually reach our terminating condition, which is x being greater than the length of a. And so if we keep adding 1, eventually x will be greater than the length of a. And we continue to do this loop until this logical statement, x is less than or equal to a, and the length of a is false. And when that becomes false, we exit out of the loop and continue on. Okay? So this is a flowchart diagram of what's actually going on here. Now, if you will, I guess up here in the right-hand corner, let's try to track the variables and see what's happening here. So we set a equal to 23, 42, 16, 8, and 12. X equals 1. So when we come out first, x equals 1. While x is less than or equal to the length of a. Well, the length of a is 5. 1, 2, 3, 4, 5 here. So let's put 5 there. So the length of a is 5. So is 1 less than or equal to 5? Yes, it is. So you execute this code block here, which in this code block we display a of x. A of x, x is 1 now. A of x is 23. So 23, if we were going to look in the command window, we would get 23 displayed. Then we come back up to the top of the while loop. We loop back up. It is a conditional, much like before. And then, excuse me, sorry, missed the critical part here. After we display 23, we then increment. So this is x now gets, and so instead of equals, if you think about it once again as the gets or the assignment, x gets assigned the old value of x, which is 1, plus 1, which now x equals 2. So when we get back up to the top of the loop, x is now equal to 2. Okay? Now we check that to see, is x less than or equal to 5? Yes, it is. So we still execute, like down here in our flowchart, we will execute this block of code. So we display a indexed at 2, which is 42, so that gets displayed. And then you come down here and we go to our incrementing again. X gets the present value of x, or plus 1, which is now, the present value of x is now 2, so x plus 1, 2 plus 1 is 3, so x is now 3. Go back to the top, we check to make sure we haven't reached our terminating condition yet. And so now, is 3 less than or equal to 5? Yes, it is, so we still execute this in this code block here. We display a indexed at x, x is now 3, so a indexed at 3 is now 16. Now x gets the present value of x, which is 3, plus 1, so now the new value of x is 4. We go back up to the top of the loop. Is x less than or equal to 5? Yes, it is. So we execute this code block again. We display a indexed at x, which x is now 4, so a indexed at x is 8. So 8 gets displayed in the command window. Then we come up here. and we increment again. So the present value of x is 4 plus 1 is 5, so now x equals 5. Is 5 less than or equal to 5? Yes, it is. So you once again execute this code block inside the while statement. You display a indexed at x. X is now 5. So now a indexed at 5 is 12. And so you come down here to your incrementing. Now you go x equals the present value of x, which is 5 plus 1. So now x equals 6. You come back up here. Is x less than or equal? Is x less than or equal to 5? Is 6 less than or equal to 5? No, it's not. This is false. So you exit out of your loop, and then you're done, which is indicated in the flow chart by doing this here. And if there were other lines of code down here, you would begin to execute those. So that's a step-by-step walkthrough of the while statement. Because we're using a loop variable here, then we're forced to sort of use the indexing method. As you can see here, we're using the indexing method. So compare it over here to the for loop. If you look, the for loop in this one step here does the initializing. It starts off as 1. It does the incrementing. Every time you come through the for loop, x automatically moves down this vector. And it does the terminating part, or the inspecting part, because once it keeps checking to see if x is equal to every value in this vector. When it has, it ends. Once again, over here in the while loop, you have to do all these steps yourself. So you have to go through and increment here. You have to inspect here, and excuse me, that's wrong. You have to initialize here. You have to increment here. You have to initialize here. You have to inspect here, and you have to increment down there. So initialize, inspect, and increment. Initialize, inspect, and increment. So that is how a while loop works. So let's look at 3 other examples, and we will continue to try to work with this concept until it becomes very lucid to you. So this is the MATLAB portion of the examples that I gave introducing the while loop. What I have up here is I'm showing the for loop implementation of the first example, which we're just doing a counting or displaying through the elements in a vector. Once again, this is the indexing method over here for the for loop, because it corresponds with the while loop and what we have to do with the indexing. So showing the similarities, differences. We're going to do this clean slate thing again because it makes things a lot neater. Clear all, clears all variables. CLC clears the command window. And so we'll call this counting while loop. So the first part's exactly the same. I can copy paste, but I like to type it. Once again, this is a good time to turn the video off and try to implement it yourself, and then turn it back on and see how you compare to what I did. So there's A. Now, once again, we've got to do our incrementing, we've got to do our initializing, we've got to do our inspection, we've got to do our incrementing. So the initialization of our loop variable x is x equals 1. Then we put our while loop in there, and then we say while x is less than or equal to the length of vector A. Okay? And then we're going to do the work part of our loop code block. So we'll display A of x, and then now we'll do, and I'll put this extra line there to separate the two. We'll do the incrementing part, which is there, and then we'll end our while loop. Okay. All right. So let's. I'm going to save that. Now, I'm going to come in here, put in breakpoints again. Yes. I'm going to come in here, put in breakpoints again, so that we can see over here in the workspace what's going on. Let me tighten this up a bit so I can zoom in better. Bring this up. Okay. So we're going to run through this. Let's see. Start execution. a of x, so our variable a gets assigned over here. X equals 1, that's initializing. We checked here while x is less than length of a, it is, so we do execute line 9, which line 9 says display a of x, and so 99 gets displayed down here. We then go to line 11 where we increment our loop variable, so now you see x is now 2, and then now we go back up to the top of our loop at line 8. And we evaluate, which is true, so we should go to line 9. We do our display again, so we displayed a indexed at 2, which is 16. Then we do our increment again, a now equals 3. We're back at the top of line 8. We do our check, so that we should pass the check because 3 is less than 5. So we go to line 9. We do our display of a indexed at 3, which is 0 down here. And then we do our incrementing, so now x equals 4. Back at the top of the loop, we pass the test again because 4 is less than 5. We display a indexed at 4, which is 89, down in our command window. And then we increment on line 11, so now x equals 5. Back at the top, we do another check. We pass because 5 is less than or equal to 5. We do display, so we display a index at 5, which is 8. And then we did increment again on line 11. And then we get back to the top of our loop at line 8. We do a test, and we fail that test, so we should jump out. And you see the arrow here is indicating we're skipping all of these lines, and we're jumping out of the loop. And then our program ends. Okay? So that's a step-by-step implementation of this counting script that we did over here with 4 in the indexing method, indexing style. We did it over here with the while.